we discussed a little bit about the corrections that we need to apply the different measurements, chain and tape measurements. If we are carrying out, we need to apply some corrections because the tape and chain was manufactured or standardized, or it was calibrated at a different environment than the one we are working at the field. So therefore, it may happen, it may be required that way. So based on those same concept, we will see few numericals today, which will, clear our concept. So this is very easy actually. One or two formulas we have to remember. Other formulas we already know. So let's see the question. A 50-meter tape has been standardized at 50 degrees Celsius. So length of the tape is given. The standardization temperature 50 degrees Celsius is given. Okay. Then it was under pull of 100 Newton. So these are the standard one. So when it was manufactured or calibrated, it is 50 degrees Celsius and 100 Newton of pull. During field measurement, the tape was supported between 2 points A and B. So we have done measurements between 2 points A and B. Elevation of A and elevation of B is given from a local benchmark. Okay. Now we have established the local benchmark. Corresponding to that, we have some elevation. So this is not the actual RL from the mean sea level. This is from a local benchmark or a temporary benchmark. Okay. Then elevation of A from mean sea level is given, and the temperature and pull at which the field measurements were done is given. So we see the temperature in the field is 42 degrees Celsius, which is different from the one at which the tape was standardized. So there will be a difference. And we also see that we have applied a pull 150 Newton, which is again different from the one when it was standardized. So there shall be a change due to this pull also. So there has to be a correction for this pull also. We have to find the corrected length reduced to mean sea level between point A and point B. Coefficient of thermal expansion of the material, tape material is given. Total weight of the tape or chain is given. Cross-sectional area is given and modulus of elasticity is given. So these are given because of this pull. Now you know this formula already, where we apply axial force in a material and there is some elongation or compression in the material according to the nature of the applied force, right? P into L divided by AE. That same formula we will use here. Now the corrections that we shall require, slope correction we will require because these 2 points are on slightly different level. One is at this RL 110.385 meter and one at 110.12 meter. So there is a slight difference between the elevation of the 2 points. So there will be a correction for slope, right? Then there will be correction for temperature because we saw the temperature, standard temperature and field temperature is different. There will be okay. Yeah. So where we were, there will be different type of corrections. We will have corrections of slope. Okay. So we will have correction of slope because the point A and point B is at different level. So if they are in the same level, then only we will get the perfect value, right? Because we are considering point A and point B. But there is a difference in elevation, so there will be a sloping, right? And therefore we will not get the exact value. Then there will be correction for pull, there may be correction for sag, and then we have to reduce it to the geodetic distance. So what it is? So it's like this. We are doing calculation between A point and B point here. and we have to reduce it to the values of mean sea level. So it may be like this. The mean sea level is somewhere here, right? Which is our datum or reference surface. So we need to find out the distance between point A and B between these 2 points at the mean sea level. So this value, we have to correct it first, then we have to find these two values. So we have to remember a few formulas. So the first formula that we are using, correction for slope. Because the point A is here, it's not a perfectly straight line from point A to point B. The point B is somewhere here. So therefore, there is a slope, right? So first we will find, okay, what is this value? So we have this formula, h squared by 2l. What is h? H is the difference between these 2 points. We are measuring A point here and we are measuring B point here. So what is the difference between point A and point B? That is our h. So first we have to take that, and that is going to be given by the difference of the RL that we have measured from local benchmark. Okay, so it doesn't matter. We don't have to have the actual RL to get the difference in elevation, right? We can consider a temporary benchmark. From there, we have taken some measurements that will also give us the difference. Okay, because we are now just concerned with the difference of point A and point B, their height, right? So the temporary benchmark or the local benchmark will also be able to give us that value. But if we require the actual RL, then we have to refer to the mean sea level. Fine. So we go there and we see that h squared by 2l is the formula. What is h? H is the difference between that two stations. It will be given by the difference of their RL. So we do that. That is h and square divided by 2 into L. L is the length between point A and point B. We are holding a tape or chain between these 2 points, which is 50 meter, and the value comes out to be this much. Now correction for slope will always be negative. Very simple, because if it is a straight line, this is going to be the shortest distance, right? A point and B point. If they are in a straight line, then they are, there is a shortest distance. If there is slope in any direction, this is going to be a value higher than the AB value, right? So therefore, the correction that we have to apply is always negative. If this is 50, then this is definitely less than 50, right? This is, say, for example, 49 or something like that. So we have to minus, then only we will get the actual value. So therefore, slope correction always negative. Then we have correction for temperature, because the standard temperature and measurement temperature is different. Okay. So we have length L, alpha is the coefficient of thermal expansion, Tm is the temperature at which field measurements were done, 42 degrees Celsius, and T naught is the temperature at which the chain or tape was standardized. Okay. So, okay, I wrote here 25, but I wrote in the question 50. Okay, so this is my error here. I wrote 25 in the formula, but I wrote 50 degrees Celsius here in the question. We will change this 50 degree to 25 degree. Okay, so 25 degree is a more suitable number, so that will be the case. Standardization temperature should be 25 degrees Celsius in this question. Okay, so here's the same formula that we use for thermal expansion, right? This is the same formula, and same thing is occurring here. L is the length of the material, length of the sample, in our case length of the chain or tip, which is 50 meter. Alpha is the coefficient of thermal expansion, 11 into 10 to the power minus 6, 10 inverse 6 per degree Celsius. And what is the difference in temperature from the standard temperature? Tm, we are 42 degrees Celsius, and T naught 25 degrees Celsius. So this value in this case comes out to be positive. So in case of temperature correction, in case of temperature correction, If the value is positive here in this formula, the correction is positive or additive. If the value is negative, the correction is negative. Okay, so we have to remember that if the measurement temperature is higher than the standard temperature, correction is positive. If the measurement temperature is lower, correction is negative. Okay, and that will be given directly by this formula. If we remember Tm to be put first, then T0. So this comes out to be positive because we are measuring at a higher temperature. There will be elongation in the material. Okay, because it was manufactured at 25 degrees Celsius, right? So this is 50 meter when it is at 25 degrees Celsius. Now the temperature is increased to 42 degrees Celsius. When the temperature increases to 42 degrees Celsius, there will be some expansion due to increase in temperature, right? Now this value is definitely not 50 meter, it is higher than that, but still in the tape or chain it is written as 50 meter. So therefore we have to add some value. So if we use that, so we will end up measuring, say for example 51 meter, but still the tape is showing 50 meter only, right? So we will note down 50 meter only, right? So there is an error over here. So to correct this, we have to apply some correction, which has to be positive. So we will remember if the temperature at which measurements are done, if it is more, correction is positive. If that temperature is less, correction is going to be negative. If it is less, what will happen, right? Say for example, we are doing at 10 degrees Celsius. What will happen? Opposite, right? It will shrink maybe a little bit. And this will be the tape. But still, we are writing down, we are measuring, say 48 meter, but we are writing down 50 meter, right? So from 50 meter, we have to subtract 2 meter. Then only we shall get the correct value, 48 meter. So like that. So we come back here. So this is the formula for correction. We already know this formula. This is the same formula we use for thermal expansion. Then correction for sag. Okay. Correction for sag, because it should have been held in a straight line, but because the tape or chain has a self weight, it will make a curve, or because we are not holding it properly, maybe something like that, it may have a curve like this. So for that, we have this formula. We have to remember this formula, L into W square divided by 24 P square. Now here there is another N in the formula when we use several number of spans. Okay, we are measuring here, then we are again measuring somewhere here, then we are again measuring somewhere here, then this N comes. So 1, 2, 3 like that. Then N will be, sorry, that N will be 3 in that case. But in our case, we are using only one tape or chain, only one distance. Okay. So therefore, there is no N here. The N value is actually 1 here. So L is the length, 50 meter. W is the weight of the chain or tape, which is 5 kg, multiplied by acceleration due to gravity to convert into Newton. I think we know that, right? This is 5 kg. So 5 kg to be converted into Newton, what we have to do, 5 multiplied by 9.81, then the unit will be Newton. So there we have 24 P square. P square is the pull that we applied. Okay. So this correction is always negative because, again, same thing, right? If it is held in a straight line, and if it is held in a curved line, obviously the curved value is going to be higher, right? So therefore, to get the real value, we have to subtract it. So the correction for sag is always negative, right? So we are writing here. So say for example, we held our chain like this and we are writing 50 meter, but this is not held in a straight line, right? If we had held in a straight line, it would have been here, somewhere here. So therefore we have to minus this value, subtract, then only we will get the actual value. So sag correction is again going to be negative always. Sorry, sag and pull, yeah, sag correction negative always, yeah. Then we have the correction for pull. Now this correction can be positive or negative depending upon what is our pull corresponding to the standard value. So let's go back here. So what we are doing here, 150 Newton we are applying, and the standard value was 100 Newton multiplied by L divided by AE. So this is the same formula that we use in strength of materials or structural analysis to find out when we have a material, we apply some axial force here, right? The formula for deflection is what? PL divided by AE, right? P is the force, L is the length, cross-sectional area, and modulus of elasticity, right? So this is the same formula. Instead of P, we are writing PM minus P naught because that is the force which will cause the expansion. The chain can take load up to 100 Newton. Up to 100 Newton, there shall be no expansion or axial deformation in the chain or tape material, right? But if it is beyond that, then only there will be some deflection or distortion like that. So what is the force causing it? The force which is greater than the standard value, okay? So standard value was 100. Now we are applying 150. So this 150 minus 150 Newton force is causing the axial deformation. So that is to be used in this formula over here. So same thing here, that PL divided by AE. P will be 150 minus 100. L is 50. Cross-sectional area and modulus of elasticity is given to us. So we found that this is positive. Now this again will come as per the formula only. If it is positive, then the correction is additive. If it is negative, the correction is subtractive. Again, if the pull is greater than the standard pull, the correction is positive. If the pull is lower than standard pull, it is negative. So even if you forget the formula sometimes, please remember always this thing, right? This temperature and pull. Correction due to temperature and pull can be both positive and negative. It will be positive when the value is higher than standard. Pull also, it will be positive correction when the value is higher than standard. Okay, please remember this. Temperature correction will be negative when the value is lower. Pull correction will be negative when the value is lower. All other corrections that we are studying about are going to be always negative or always subtractive. So please remember this. Then now we shall apply the total correction. Okay, so we will just add them up. We will keep their signs as it is because that is important. And we found that this is our final value. So this will be applied to the designated value, which was 50 meter. 50 minus this is comes out to be this one. Now this we got, this value we got between point A and point B at the ground level. Okay, this is the corrected value at the ground level. Now this value is to be converted into the value which is at the mean sea level. Okay, so obviously again this value is going to be smaller than this value, right? This value is going to be smaller here. So again, this is going to be subtractive in most of the cases. If we are carrying out our measurements above the mean sea level, then this value is going to be always negative. And which is the general case, right? We will always be above mean sea level in most of our calculations. So for that, we have this formula, L into H divided by R. L is the length, which is 50 meter. H is the actual elevation now from the mean sea level of the A point. That is given to us as per the equation. And then what is R? R is the radius of the earth. So 6371 kilometer is the average value multiplied by 10 to the power 3 to convert it into meter. Okay, the value is going to be negative. So we apply that and we see our final corrected distance. Okay, fine. Please go through this once again. Okay, after the discussion is done, it is uh, not that difficult, right? It is very easy to understand. Then we will go to the next problem, very small one. We have a tape 30 meter, okay, but it has an actual length 29.995 meter. Okay, this is correction due to absolute length. It is not due to temperature, not due to pull or sag. It is actually short but written as 30 meter. The tape was standardized at a temperature of 38 degrees Celsius, and during measurement in the field temperature was 22 degrees Celsius. Find the true length of a line recorded as 8560 meter. So the tape has some defect, the tape or chain has some defect, but we have already measured a distance somewhere and we have already recorded this distance, right? How much? 8560 meter. We have already measured using this tape or chain and we have already recorded 8560 meter. But we now know that there are some defects, so we have to correct it. How we will do that? So first, correction due to absolute length. Because it has some defects, it is not actually 30 meter. So actual length minus designated length. So what we were doing, actually this is not 30 meter. Actually this is 29.9 meter. But we are noting down 30 meter, right? We noted down 30 meter. So for correction, what do we have to do? This is the real value. For correction, we have to minus the 0.1 meter, right? That is our correction. So this correction is going to be negative. So we will write actual value minus designated. Now the actual value, if it was higher, 31 meters, say for example, then this correction is going to be positive. So we will always write actual value first, then designated, then as per the sign we can give the correction. Or you just remember the concept, you will definitely understand, right? Very easy. Then actual length is 29.995 meter and designated is 30 meters. So this is the correction to be applied in each tape or chain length. Then correction due to temperature, that same formula, L into T into alpha. So L is 30 meter, T is what? It is the difference between measured one and standard one. Measurement was done at 22, but the standard is 38 degrees Celsius. Now we are operating at lower temperature. So therefore, the correction will be negative. And we have this coefficient of thermal expansion as it is, so we get the value. Now, total correction per tape length is this much. Okay, we are not doing other correction, pull and all, because that is not provided as per our questions. Data of pull, data of weight of the material, these are not provided. That is why we are assuming those corrections are not required in this question. If they were required, the data would have been provided to us. So correction per tape length is this much. Then we just have to do this unitary method. So while measuring 30 meter, this is our correction. While measuring 1 meter, this is our correction. And while measuring 8560 meter, this is our correction. Minus 3.0154 meter because it is negative. So from the final value, we have to subtract this value to get the answer. Again, I have made a mistake here. Please correct it in your records. It should be 85 something 60. So it will be 57 something. It's an error here for me. Okay. So just write the correct value, which is 8560 minus 3.0154 meter. That will give us. Okay. So that will end these two numericals for us. Then after that, we have this triangulation. This is the definition of triangulation is given here. Sorry, triliteration is given here. Triliteration is a process which is similar to triangulation, where we all make triangular networks, but we don't measure the angles. Okay, we will measure the distances of these sides. So it's the same principle. We go like this. We measure one triangle. and we go like this, right? Somewhere, something like this. So in triangulation, what we do, we have three stations like this. One side we will measure, and all angles we will measure. Then from the angles, we will use the sine rule, small, this sine rule, and we shall find out the length of this side. What is A? A is the length of the side which is opposite to the angle A. What is small b? Small b is the length of the side which is opposite to angle B, like that. But in trilateration, what we do, we don't measure the angles, we measure the sides, the distances of the sides directly. So that is the only difference between triangulation and trilateration. Only one side, which is baseline, then the angles. And in trilateration, the sides are measured. All the sides are measured. No angle measurement. But at few cases, what we may do, we may measure the azimuth or bearing for checks. Okay. But the general process will be measurement of all the lines. So please see this one. This is just theoretical only. You will understand. There is another word, trilateration, which we should not confuse. Trilateration used by GPS. When we will study the GPS, we will see that maybe you know this already. When we use the GPS system, how the satellites determine our location, right? So that is also trilateration kind of. So it is given here, explanation. We have one satellite, we have two satellites, we have three satellites. And this is the receiver who is using some kind of GPS device. So what will happen? The satellites will make an like this. Okay, this signal is coming from a radius like this. Another satellite will make a, okay, this signal is coming from somewhere like this. Another satellite will say, okay, this signal is coming from somewhere this. So the location will be here like this. So to find out the location of a point using GPS system, we need at least 3 satellites, and for proper working, we need at least 4 satellites. We will see that when we study GPS systems. But for the time being, you just know what is triangulation, what is trilateration, and this trilateration that we are studying now is different from the trilateration concept used in GPS system. So that will do for the time being. We will end here for today. If you